May, dear listeners. I hope everyone is in great health and everyone is ready in your house, in your office, or in the car to listen to your podcast. For this episode, apart from the News Mini section, we have a very special book title reviewed by Haluk. And we have Dr. Shadonbar as our special guest for interview. So I don't make you wait for too long and let's start. This is Dr. Maryam Kaveshkar and this is the News Mini section for episode 46, May 2018. Let's start with the aftermath of Uber incident. Nvidia said it will stop its autonomous car testings as a consequence of what happened with one of Uber's cars, and there was a fatal accident. Uber is one of Nvidia's customers using the Nvidia's computing platforms. At the moment, Nvidia's system is being tested in New Jersey, California, Japan, and Germany. A Nvidia spokesman in their annual GPU technology conference in San Jose mentioned that they are temporarily suspending the testing of their self-driving cars on public roads to learn from the Uber incident. He has added that their global fleet of manually driven data collection vehicles continue to operate. Toyota also has joined and has said that it would pause the testing. Nvidia has been the topic of our News Mini section many times. It has, as itself claimed, 320 clients in the automotive space. Is Tesla still racing against Nvidia? Maybe. This is the reason the Tesla started making its own chip and thinks of having the hardware of its own. However, on the other side of the world, in China, the Ministry of Industry and Information Technology, MIIT, has released the national guidelines for autonomous driving tests and specifically for smart internet-connected cars. MIIT also mentioned that foreign countries can apply for tests in China, considering the regulations and providing the full responsibility for any possible accident. And all this after 4 months that Beijing has opened its roads to test driverless cars, and in March Shanghai joined the crew. Well, as Rolf Speth, the CEO of Jaguar, phrased, nobody can go it alone in autonomous driving. Alphabet Incorporation's Waymo has mentioned that by 2020 will add as many as 20,000 Jaguar I-Pace electric to its fleet of taxi service. MIT scientists have developed a system that can find the obstacle and give the distance to them even in the thick fog. Thick fog was one of the nemesis for designers. The light-based detectors had difficulties to tell the distance, so radar-based detectors were always more preferable. This step has solved a big issue. Guy Satat, a graduate student in the MIT Media Lab, said, I decided to take on the challenge of developing a system that can see through actual fog. He led the research. Also added, we are dealing with realistic fog, which is dense, dynamic, and heterogeneous. It is constantly moving and changing with patches of denser or less dense fog. Other methods are not designed to cope with such realistic scenarios. They have used an ultra-short laser impulse and a time-of-flight camera. BMW has promised to bring autonomous cars by 2021, however, has been quite tight-lipped in the past year. This week, it had a deal with Innoviz to bring solid-state LiDAR scanners for its driverless car technology. Innoviz is an Israel-based company and has told that the cost of their LiDARs would be a few $100s. Innoviz provides software to develop a 3D point cloud image of a scanned area along with the hardware. Let's finish our section with some news from the subcontinent of Asia. India is going electric. Ola, the Bengaluru-based ride-hail platform, has announced that will put 10,000 EVs, or better to say electric auto-rickshaws, on road by 12 months. And this is 1 year after that Ola, with partnership with Mahindra, set a plan to start an electric mass mobility in Nagpur. The firm did not comment where, but they are planning to expand the plan to 3 other cities. Further on, the government of India is taking new measures to ease the access of electric vehicles. They just announced that e-vehicle charging stations need no license. Well, that it is from News Mini section. Thank you for being with me now. I ask you to sit back and carefully listen to Haluk Aaron from Farad University, who has chosen a very different title this time for us. The book is about aeromedical transportation. Please, Haluk, go ahead.
This is the book review section for ITSPodcast, reviewed by Dr. Haluk Aaron, Farad University, Elazığ, Turkey. The book title is Aeromedical Transportation, a Clinical Guide, and consists of 313 pages. Produced by CRC Press in 2006. Written by Terry Martin. This book introduces aerial patient transportation issues. It also provides a well-promotion for initiatives to enhance the related standards. The book contains key technologies and other matters for aeromedical transportation. As experiencing Transportation 5.0, the underlying matter has a serious potential for new research areas in next decades. For instance, in the road transportation domain, we are investigating driver or driving behavior using driver, vehicle, and environmental factors. However, in the aeromedical transportation case, we should consider patient responses and all the crews and equipment qualifications, involving in air vehicles such as rather a wing or fixed-wing aircrafts, like small jets and turboprops. Aeromedical transportation is engaging with aerial rescue of patients by flying into the bottle and fighting with the wind. It is an attractive mix of physics and physiology of aeronautics, clinical care, and the thrill of flight. In the age of international travel as the globe shrinking, aeromedical transport has become an integral part of life. The new aeromedical transportation era brings new challenges, meaning promising research issues like fuel costs, international terrorism, larger aircraft, medical equipment for transportation, critical expensive care, administration, demands for training, improvement and documentation of standards of care, qualified aeromedical crew, optimum evacuation route, human factor, search and rescue, disaster management, atmospheric conditions for a special transport, patient-related matters, and ever-increasing legislation. The book consists of 3 parts and 21 chapters. Part 1 starts with introduction comprising history of aeromedical transportation and overview. An understanding of the atmosphere and its basic properties is vital in aeromedical practice. The physics of the biosphere provides a comprehensive knowledge of altitude and aviation physiology. Part 2 includes physics and physiology. The section comprises the atmosphere, the physiological effects of altitude, the biodynamics of flight, transmeridian and long-haul flights. Part 3 consists of operational considerations. The section speculates on operational aspects of aeromedical transport, the medical flight crew, and aeromedical equipment. Part 4 discusses clinical considerations. It encompasses indications for aeromedical transport, clinical considerations in transport of the ill and injured, transport of patients with spinal injuries, transport of burns patients, transport of the obstetric patient, transport of neonatal and pediatric patients, critical care transfers and retrievals, and nursing care in the air. The last part mentions about organization and administration. The section elaborates the administration of aeromedical transport organizations, medical legal aspects of aeromedical transport, planning the successful international repatriation, and primary transfers for the casualty evacuation conflict. Building a carrier in aeromedical transportation may be an effective gate into this field, if you like traveling with emergency helicopter or aircraft. This book provides rich information for the readers interested in aeromedical transportation issues and practices.
Thank you, dear Haluk, for one more nice review. Now it's time to sit back and listen to our interview with our special guest, Dr. Eshed Onbar. Today we have Dr. Eshed Onbar as our special guest. He currently works as a researcher in the Robotic Institute at Carnegie Mellon University. He is interested in machine learning and computer vision for mobile assistive and autonomous systems. He has received the first prize for the Best PhD Dissertation Award given by the Intelligent Transportation Systems Society, given at the 2017 Intelligent Transportation Systems Conference in Yokohama. Hi Eshed, it is great to have you here today.
Hi Mariam, thank you so much for having me.
You did your PhD in the Lab for Intelligent and Safe Automobiles in the University of California, San Diego, under the advisory of the well-known Professor Mohan Trivedi. Can you tell us a bit about your dissertation research?
Definitely. I envision a world with no road traffic injuries. To achieve such a goal, I work on providing intelligent vehicles with the ability to understand and interact with humans that are all around them. Actually, human-centered intelligent vehicles is pretty much a summary of my PhD work, but also much of the research at LISA.
Well, how do you first become interested in computer vision for intelligent vehicles?
It was in the first year of school, of graduate school. Before, I was not too familiar with computer vision, actually. I was studying pure math. And then I taught math at a high school in Los Angeles. But in the first year of graduate school, I took a class with Mohan and did a project for gesture recognition with Kinect. So we're talking about simple gestures like swiping. I really liked it, and we tested it in the car and used it to monitor the driver state. The RGB data from the Kinect was used to detect driver gestures and secondary tasks.
Considering that it has been several years since you first began this research, do you see an application for it in today's world of self-driving cars?
I think it's still relevant. Basically, intelligent vehicles must learn to safely collaborate with humans inside the vehicle or around the vehicle. Consider drivers in other cars or pedestrians. We eventually extended this gesture research project to predict human behavior in such scenarios. Predict what humans will do in the near future. This idea, which has been studied for a long time in ITS society, is so important for any type of human-robot interaction.
Besides modeling and predicting behavior of humans in and around vehicles, do you see additional research challenges which you are excited about? I think our audience and new PhD students will be interested to hear.
Sure. We, human drivers, we don't just treat other humans as obstacles, but we constantly employ what's called common sense. We reason about the goals and the behavior and the subtle gesture cues of other humans. And it's really challenging to encode this type of information into an algorithm or a black box. So I think it plays a role in developing the next generation of intelligent systems.
I see. Teaching cars common sense about humans.
Yes. And also, humans don't just have to be observed passively, but they can actively involve in the training process of algorithms, which is something we worked on towards the end of the PhD. I think actively incorporating different feedback from the human during training is a promising future direction of research. Actually, we used it to train an algorithm that perceives the environment like a human driver would, giving more attention to a crossing pedestrian or a risky situation.
Is this research related to your current work as a researcher at CMU?
Yep. One of the projects that I'm currently involved in is also very related to intelligent vehicles. It involves navigation, but in indoor environments. We are tackling assistive robots for people with visual impairments. Guidance under these type of settings definitely involves complex interaction with the human end user.
So does that mean you have changed the field, or are you still planning to stay on ITS in the future?
I think my research is still intelligent systems research, but a bit more interdisciplinary. It's really an extension of my PhD work. It's highly rewarding. Altogether, I like to think that I helped in contributing to being able to assist a blind person to their destination, all the way from calling an autonomous vehicle to their doorstep and up to step-by-step instructions to the gate at the airport or the doctor office in the hospital. Computer vision, human-robot interaction are just as important here, but of course, there are some differences to driving on the highway.
Ishit, do you have anything else to add for our podcast listeners?
I want to take a moment to thank the Intelligent Transportation Systems Society. They provided a supportive research community for me all the way from the beginning of the PhD.
Thank you for your time and thank you for being with us.
Thank you, Mariam, for having me.
Dear listeners, don't forget to subscribe and share. And if you are interested, please give me a sign and you can join our podcast as a volunteer. Thank you for being with us.